Hey mathematicians, here are notes 3.2, solving equations using addition and subtraction. So before we jump into learning all of our new skills, let's talk about this bell work. What does it mean to solve an equation? Or why do we want to solve an equation? Maybe even how does one solve an equation? I got a little excited and I already wrote down the first answer, so you can see I'm hiding it with my pencil here. But take a minute to think about that. What does it mean to solve an equation or maybe even solve a problem? In our case, solving an equation means to get an answer or to get a solution. With an equation, that usually means that the variable is all by itself. Well, why do we want to solve an equation? Early on, solving an equation just means we get an answer. But later in math, we're going to use our solution from the first equation to potentially help us in other equations. So, the answer may be useful in later problems. And how does one solve an equation? Well, the easy answer for this is to get the variable alone. You'll see that that's an easy answer right now, but it may be a little bit harder when we actually start looking into it. So let's jump in and see what that means to actually get the variable alone. Today's goal is to be able to solve a one-step equation using either addition or subtraction. We're not going to jump into multiplication or division yet. We're just going to start with the easy stuff. So what is the addition property of equality? That basically means that whatever you do to one side using addition, you must do to the other side using addition. So in this case, if I want to get the variable alone, I notice that I'm currently subtracting 9 from x. If I want to undo subtraction on that side, I have to add 9 to that side. And why am I doing that? Well, essentially, if I do that on the left side, it's going to cancel out that minus 9 that's giving me a hard time. But again, addition property of equality means that whatever you do to one side, you have to do to the other side of the equal sign. And sometimes I find it helps if you draw that little dotted line to remind yourself that you have to do it to both sides. Well, now that we've added that 9, what does that problem look like? As I said, it cancels on the left, and we're left with just the variable x. We still have an equal sign in the middle, but now we have to simplify our right side. 47 plus 9, in this case, is going to be 56, and you'll notice that we've correctly solved this problem because we have the variable by itself and everything else on the other side. We can also check our answer by plugging it back in. If x is equal to 56, there's no reason that I shouldn't be able to put 56 back in where x was and say 56 minus 9 is equal to 47. If that works, I did do the problem right. Let's see that again. Notice this problem, we have negative 51 plus x equals 33. I want to get my x by itself. In this case, it's a positive x, so we don't have to do much with it. But I've got this pesky negative 51 over here. And if I want to cancel out a negative 51, I need to add a positive 51 to it. But whatever I do to the one side, I must do to the other. On the left side, these just cancel out. But on the right side, we have to do some more simplification. All we're left with on the left side is x, but on the right side, we now have 84. And again, I am now finished because I have the variable by itself, and that is what we defined solving an equation to be, getting that variable alone. Notice there's no other numbers by it, there's no other signs, no negatives or anything. And when I put it back in to my original problem, negative 51 plus 84 should equal 33. We did the problem right, we checked ourselves, and we're good to go. Next up, we're going to look at the subtraction property of equality. The same way that we can add to the left and right side, we can also subtract from the left and right side. So I'm going to throw my dotted line here on the equal sign to tell myself which is the left side and right side of the equation. And I notice that if I want to get x by itself on the left side, I have to get rid of a positive 15. If I want to get rid of positive 15, I should probably subtract 15. But we have to keep it equal. That's the equality portion. We have to also do that to the other side. Once we've done this, you'll notice those 15s cancel out, and I'm left with just my x. On my right side, when I do 45 minus 15, I'm left with 30. Again, since my variable is by itself, I box my answer to indicate that I am done. I could throw this answer back in, but I'm actually just going to move on because you've seen it over here. However, I would like you to continue checking your answers until you feel confident. This one is actually a little tricky, and the reason is because we've got a double negative here. Just as I said in my other video, we always want to simplify those double negatives before going further. Instead of trying to solve this problem on a left and right side, I'm actually going to simplify it to be x plus 42 equals 40. Now, it's a lot easier to see that I have to subtract 42 from each side, whereas before it might have been a little bit hard to see whether we were going to add 42 or whether we were going to add a positive. Either way, it was kind of tricky to see. Now that I've got it simplified like this, the left side cancels out, and I'm left with just my x on the left side. On the right side, 40 minus 42 results in a negative 2. And because my x is all by itself, we're good to go. Drill and kill mode activated. I want you to drill and kill these problems so much that you cannot get them wrong. One of my favorite quotes out there is, don't practice until you get it right, practice until you cannot get it wrong. So let's jump in here. I want you to pause the video right now, see if you can do these on your own. Let's stop at the special case. We haven't done those quite yet. And then, when you're ready, come on back, unpause the video, and we'll go through them together. All right, hopefully you had time to check those out on your own. Let's jump into it. This first case has a subtraction, so I'm going to need to use that addition property we talked about. Whatever I do to the left side, I must do to the right side. You can think of it like a teeter-totter. In fact, I'm going to use that often. So if you do it to the left side, you must do it to the right. This is actually the exact same problem from up above. Hopefully you saw that. But x equals 56. As usual, I'm going to ask you to box your answers to make it really clear to me. Next up, we've got y minus 28 equals negative 3. We've got another subtraction. To undo subtraction, we need to use addition. Whatever you do to one side, you must do to the other. These cancel, and I'm left with y equals negative 3 plus 28. When I simplify that, I get y equals 25. Notice it's totally okay that I'm not using x every time. X isn't the only variable, it's just the most common one we use. Here's another one of those tricky ones. We've got a double negative, so I'm going to simplify and then solve. Notice I have a positive 7, so I need to undo that. Both sides. It cancels over here and leaves me with just an x. 12 minus 7 is 5. Again, you can be checking these on your own by plugging that answer back in. I'm not going to for the sake of time. We have plus 19 on the left, plus 19 on the right. Notice I'm always working with the number that's closest to the variable. I'm not adding 8 because that would give us a 0 on this side and a bigger number over here, and that wouldn't solve our problem. We're always trying to move this number away from the variable, never towards it. We're left with x on the left and 11 on the right. Again here, we're moving this positive 22 to the other side. We want to get it away, so we're going to subtract it. Whatever you do to one side, you have to do to the other. W equals negative 20. This one is another tricky one. You've got a plus -9. Guess what? Adding a negative number is the same thing as subtracting a positive number. So I can actually get rid of that positive because it doesn't change the problem at all. Now that I've done that, I see that I have to add 9 to get it away from the y, to get it canceled. And when I add 9 to this side, I get y equals 31. Last ones. These are some special cases. Now, these are tricky because we've got a negative in front of our variable. And the way that I'm going to avoid this right away without using a product or a quotient rule at all, I'm just going to make that positive by moving it to the other side. The same way that we can move numbers, we can also move letters. If I say plus c on the left side, I can also say plus c on the right side. Notice that then cancels out on the left. I'm left with just positive 10 equals, and I'm going to put the c out in front because it's a positive c, c minus 5. Now that I have a problem with no negative out in front, I'm going to move that positive, that negative 5, make it positive to go to the other side. So plus 5 to get it away from that c, do it to both sides, and I'm left with c equals 15. This answer is perfectly okay. I personally always prefer my variable on the left, so I rewrite it as c equals 15. Doesn't matter which way, however, because they're both correct. That's just the first method for the special case. The second one I'm going to show you, 6 minus b equals 8. Actually, I'm not going to show you that method quite yet because we haven't gone through word problems. Same thing. Let's get rid of that negative b by adding b to both sides. Notice there's no b to add over here, so we're just going to add it to the 0b that's technically there. 6 equals positive b, this is a positive 8, and then of course let's get that positive 8 away from the b by subtracting, so that we're left with b equals -2. Put that variable on the left side, -2 goes to the right, b goes to the left, and nothing's changed. Just like that. Alright, let's take a little bit of what we learned before and actually bring it into this lesson. Let's translate the following into an equation and then solve it. Yesterday was translating, today was solving. Let's do it all. The difference of b and 1/2 is -2. The difference of indicates parentheses. The difference of also indicates subtraction. So the difference of b, difference and 1/2 is, that's our equal sign, -2. Now, even though there's parentheses, because there's nothing going on outside of the parentheses right now, they're not super useful. So I can rewrite this without those parentheses, and that's okay as long as there's nothing, say, out in front being multiplied. How do we now get our variable alone? Well, right now there's this -1/2. In order to get that to the other side, in order to undo a -1/2, we have to add 1/2 to the left and add 1/2 to the right. We're then left with a b on the left and -2 plus 1/2. I'm going to jump up and over here for space to see that b is equal to -2 plus 1/2. That would be -1 and 1/2. B is now by itself. We're happy. So we box our answer. Just double checking, there is nothing on the back side, so I encourage you to practice, 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 and if you have any questions at all, let me know.